want to talk to you about the whole process that has taken more than 20 years. But first, what's my motivation? And one of the things I've realised talking or listening this morning is actually my motivation and many of my learnings are actually the same across multiple fields. So my motivation for doing this research in the first place was to help my community, to improve healthcare and improve the New Zealand economy. And I've always felt, since I was a child and had a professor as a father, that good research should affect people's lives. And if you're going to affect people's lives, you've got to get that into the community and have societal impact. So my ethos is do the science and deliver it to the community. And I think that actually aligns very well with everything we heard this morning. So what is my science? Spectral photon counting, new technology for measuring X-rays. So there's a technology of how we do it, which gives us much higher spatial resolution, much lower dose, and allows molecular imaging to occur. The technology is also actually interesting compared to, say, traditional CT and MRI, as it's extremely well suited to point of care. The lower X-ray power means you can use it in unshielded rooms. It means you don't need water cooling for your X-ray tubes, and the machines can be made smaller, making lower capital costs and lower ongoing costs. So there's kind of two domains of benefit: better imaging and better delivery. As I said, it's been a long time. The essence of this actually started in about 2000 when a bunch of New Zealand scientists joined CERN to study particle physics. By about 2010 or 2007 or 8, we had proof of concept of the technology. By 2010 we were selling the technology internationally for medical schools. So the first one went to the Mayo Clinic and they've gone to places like MD Anderson, etc. around the world. We then translated it into the human compatible technology. It was actually quite an interesting technology challenge. We then developed some first clinical applications or beachhead applications, and then we're now aiming for widespread adoption. So what does that mean? On the left, that's a spectral image of a fetal hand and beside it a mouse. The fetal hand took till 2006 to prove we could measure images in a suitable way or measure the X-rays in a suitable way. And then that mouse chest took about 24 hours to image and about a week to process. So over those first 7 or 8 years, we managed to prove the technology works and we could do something new with it. We then went on and started selling it to medical schools, and it was being used around the world and still is being used around the world for cancer research, cardiovascular research and orthopaedic research. We then translated it into humans and demonstrated we could work in the higher energy ranges needed, but as you can see from the picture of the scanner and my father on it, it's very much a physics experiment and a proof of concept. We then put it in a point of care system, and so these are patients from New Zealand. It's just a wrist scanner. It's the first clinical application. We've now got all our New Zealand compliance done, and that's funded by ACC and Southern Cross now. And in future, we hope to produce a range of scanners. I haven't got a point here, so I have. What's the benefit in point of care? This is a hospital in the US. The top line is outpatient. Bottom line is inpatient. By having point of care systems, you can drive the care back into the community, reduce cost, reduce wait times, improve access. So that helps everyone. And so if you move that into other market verticals or other clinical applications, there's a wide range of benefits possible. So how is it funded? This has been converted, but the top line there is meant to say grants, and then there's been investment from the New Zealand commercial industry, US investment and sales. If we start with the grants, the first one that led to this was actually the New Economy Research Foundation, and I was talking to one of the scientists involved with that, and that was meant to have a 30-year outlook for New Zealand economy, so they're about right. We then got some tech money to develop and some infrastructure, improve grow some PhD students. Fourth Man let us take it to medical researchers. That's actually a medical school in the US, that picture. MBA gave us some money to take it through into human imaging. First New Zealand investment, family and friends, about 2010. We're now backed by Pacific Channel and other VC firms in New Zealand. And that's about $20 million which is about the government input so far. More recently, we've had investment from a hospital system in the US, Hospital for Special Surgery, the world's largest orthopaedic hospital system. They purchased part of the company and are now working on the 510K and the clinical rollout in the US. And in fact, we've also got a US investment firm who've given us a letter of intent to invest in the company post FDA compliance. Total investment there, I think, is about 20 million as well. And then sales, 10 million research sales from exporting this technology. And then the clinical stuff in New Zealand is now funded by ACC and Southern Cross. And in the US, our partner is looking at trials to confirm that the insurance company and the reimbursement will occur. So what are my learnings from this? Actually, I wrote this about a month ago, or a few weeks ago, and then I realised again that it lined up fairly well with what we heard this morning. You need to aim for impact. So your goal is to improve the community or do something to help someone, and then you do the science that's necessary for that impact. You're not just following your nose to an interesting question. If your goal is impact, focus on the science that gets you there. You have to align your science and business plans. We saw that this morning, of course, whereas here in my project, we had a science plan that said we need to sell to medical schools. We need to know how our product is going to be used, whether we should be going for cardiovascular applications, orthopedic applications. And so those 10 years when we were just selling to medical schools not only brought revenue in, allowed us to develop the product, it actually has carefully let us segment the clinical market to the order I think they will arrive. So for example, I suspect, or in fact we're working on the orthopedic market because the barriers to entry there in terms of what the technology can do are very low. Whereas if you move to the oncology market, spectral imaging is actually quite likely to replace PET in a lot of nuclear medicine, but requires pharmaceuticals that come in parallel. So you can stratify what order you're going to go through the market based on feedback. The other thing I think has been critical is early engagement with end users. Now, I've been on grant panels and things where we've gone out and we've spoken to end users. In this project, and we heard it again this morning from pretty much everyone, you don't just go and talk to the end users, you work with them. You find out what they need to do, you run your experiments with them. So for those early medical schools, we were assisting them in helping develop the technology to meet their experimental needs. And now with the hospitals, we're working directly with them to find out what will improve their patient flow. And the feedback for us is that they're going to give us economic analysis of how our technology actually saves their hospital money. So I think those learnings are actually common amongst everything, but they've really have shaped my career. So thank you, and I think we have questions at the end.